Good afternoon. I'm Ed Conjura from the College of New Jersey, and I'm here to talk about developing and implementing a technology plan for educators. I will go over what we did at the College of New Jersey and our experiences over the last 12 years. I'm Ed Conjura. I'm at the College of New Jersey, and I'm here to talk about developing and implementing a technology plan for educators. I have a subtitle for it. Getting the horse to the trough is sometimes easier than getting it to drink, okay? And I think you'll understand why as I talk. My presentation, I'll give you a little bit of background about me, the College of New Jersey, my definition of what a technology plan is, the importance of phasing it in, and most of my time, my short time, will be talking about creating faculty technology profiles, which is what I did first, identifying key courses. If you want to go someplace, you have to know where you are, so determining the status quo. You can't do it by yourself, so identifying key faculty that are going to help you pull something off, and then getting feedback into the loop so that you can make improvements and using students and employers and other faculty too. And then I'll end with where we are and where we're going. And then I don't know if we'll have time for questions. I'm a pure mathematician by training. I've had a lot of programming experience. I actually did assembler. I saw that assembler yesterday and I cringed because I hated it. And some of you probably have never heard of some of these languages. APL, anybody hear of APL? A programming language, yes, And then I moved on fourth. I actually co-wrote a textbook in fourth. Pascal, Basic, C, C++, Mathematica, I guess that's the curse word I'm not allowed to say here, MATLAB, and Visual Basic, Java, Python. So I programmed in a lot of languages. My first real exposure, I used Mathematica before I went to Rocky Mountain Mathematica. Stan Wagon, who's here, he's giving a talk, and he was great. That was back 1999. 2000, and I came back so inspired. I said, boy, I'm going to get everybody in my department to use Mathematica in their courses. And so first, a little bit about the college. Roughly 6,600 undergrads. There are some grad programs, but only a few. We have about 355 faculty. We have schools of science, engineering, business, social science, humanities, art, music, and nursing. My department has a lot of majors, 300 majors, believe it or not. They're in 4 programs. We have what I call pure math, but the pure math don't like to call it that, so they just call it math. And we have applied math, we have statistics, and math education. Here's my definition of a technology plan. Okay, it's a working document that's backed by consistent and ongoing effort, and it's designed to help infuse technologies, such as Mathematica, but others also, into classroom instruction and guided student research. I see 3 key ingredients. You have to start with a set of competency guidelines that you want to shoot to try to achieve, okay? You need to get a lot of help, both inside and outside. And then you have to have a driving force, someone who's going to keep it going and keep us all on task, all right? Now, when I drafted the technology guidelines, I described 3 levels. And level 1 is just exposing the students to technology with a focus on visualization. So you want to show that technology can aid through demonstration. Demonstrations are great. And doing complicated computations and using it to solve complex math problems. But I want to note that for level 1, the focus is not on assessment. It's to get the students turned on to use it. In level 2, you embed it entirely into the learning process, and so students are taught how to use it when they're studying, in my case, mathematics and statistics, and then it becomes part of the assessment process. So you want to make sure they understand it, and it plays a part in assigning them a final grade too. Level 3, which is the ultimate as far as I'm concerned, the students are able to apply technology to solve difficult and possibly open-ended problems, which I do give to my students, where there's not necessarily a specific way to do it. and then they have to design algorithms and implement the algorithms to produce a working solution to the problem. Okay, outside help. It helps if you have a dean who'll give you a 4th hour to add to a course so that he can use technology. And the old dean did. I was the dean before that, and the one after that did. But the new one isn't quite as generous. Okay, he says if you want to do it again, you have to take it from one that you got it in before. It's nice to have people at Wolfram. Andy Dorsett's my contact here. He comes to campus periodically and gives seminars to the faculty. And I wanted to get the licensing agreement so that all the students could download it. And I finally convinced my dean to do that, but it was with Andy's help explaining the benefits of it. And you have to have other faculty who are willing to help you gather information and do coordination. And that's the toughest part, as you'll see. Driving force, somebody, you or somebody else, has to be willing to do it. At our place, it's me, so I'm the driving force that sort of cracks the whip. Now, phasing in the process is very important, and between 2002 and 2004, I call this How Not to Start. And you might say, well, you know, myself and 2 other colleagues wrote an NSF grant proposal, and it was funded, and the title of it was Introducing Software Tools into Linear Algebra and Principles of Math, which is now called Proofwriting Through Discrete Math. And how could that be a horrible way to start? Well, I took the Principles of Math course, and my 2 colleagues took the linear algebra. So I developed all these Mathematica modules for this course, and there was a 4th hour. The reason it was good, but it was a disaster. There were 2 of us teaching the course, me and a logician. Are any logicians in here? This logician didn't have a cell phone, didn't use Excel, hated technology, right? So I'm teaching it, and he's teaching it. And I'm covering 10 chapters, he's covering 8 chapters. In addition to me covering 10 chapters, I have all these Mathematica modules that students have to work on. The good students loved it. They were getting more bang for the buck in the course. But boy, talk about student feedback. A lot of the students were saying, why do I have to do all this extra work when I could have taken the course with Professor X? So you have to be careful. If you wish for something, you might get it, all right? Worse yet, after being in academic administration for over 20 years, I gave up the chair job, and then the new chair didn't care about technology at all. So between 2005 and 2009, nothing happened. And to make it even worse, I wasn't even teaching the course, so the people teaching the course rewrote history. All reference to technology in the course disappeared. And I sneak it in when I teach it. Anyway. But in 2010, I wrote the first draft of the technology guidelines, which was more inclusive than what I showed you. But in between 11 and 12, I started the phase-in level 1, and by identifying courses, and I'll talk about that in a minute. And then between 2013, continued level 1, started to bring in level 2, and officially I would say level 3 started last spring, but I was doing it before that. But since I was the only, well, me and maybe one other person, I don't really count that. But now I have more people bought into doing level 3. Okay, gathering information. I created a profile on all my faculty. I identified key courses. I determined the status quo. Pulled in the faculty that I knew would be willing to help me, and then use the feedback. So what did I do as far as the faculty is concerned? First, I gave them a survey. The first question was, do you own a cell phone? Second question was, do you use Excel? Do you use Word? Do you consider yourself to be a novice, an average user, or an expert? Next thing I asked them was, do you program? If you program, what languages do you program? And how many programs have you written in the last year? And do you use it in your instruction? Do you use it in your research? And if so, how? After I got all that data, the second thing I did was I sat down with every one of them. I had the data, but what I wanted to find out, who would buy in? So I wanted to find out who had apprehensions, who had fears, and where was their lack of enthusiasm, so that I could target different faculty to teach the courses that I thought would in fact, do the job, okay? As far as which courses, this is only a partial list, but Calc A and B, all the Wolfram demonstration project, I had written a ton of stuff in Mathematica, so that was perfect for level 1. The linear algebra came out of the grant. We had developed all the materials using both MATLAB and Mathematica, so we had both labs in both of those. For level 2, there was a colleague who sat in on a course that I developed, the computational math class, and he became excited, and so he teaches Calc C, so he used the Wolfram demonstration project and developed his own materials, so he bought into it. I always thought number theory was a perfect course for the use of technology, and so one professor uses Mathematica, another one uses Python, and that's fine, as far as I'm concerned. In the ODE class, there are, again, 3 professors. One uses MATLAB, one uses Mathematica, and the other one uses both, sometimes neither, so it's a hard one to keep in line. Now, as far as level 3, officially last spring when I taught the computational math class, that's definitely level 3. The applied math capstone's level 3, and even in the pure math capstone, they use some technology. So we have it going at level 3 in those courses, and the upper level stat courses use it a lot too. So this is, as I said, these are partial lists. Okay, how do you determine the status quo? You do survey. You collect data and you use the data. I would, when I picked the elementary stat courses as the targeted level 1 sequence of courses, I surveyed all the instructors, both regular and adjunct faculty, because the course syllabus said they were using technology, but to my surprise, when I did the survey, there was only one instructor who was actually using it, and that was an adjunct professor, which made it even worse. So I went to the stat committee and I said, hey, the department's bought into this. We want technology in there. You need to do something about it, and they've since done it. So all the stat courses now all use some type of technology. Key faculty. I have a faculty coordinator for Calc A and B, and the job of the coordinator is to form a repository of all the materials that people are using, put them in a place where other people can use them, and then ask them questions at the end of each semester. How did you use it, and what do you think, and were there any shortfalls or things like that? I have a faculty coordinator for Calc C. He's the guy who sat in my computational math class. And there are 3 people teaching that course, and 2 of them use Mathematica exclusively. The third one uses it for demonstration, but not at level 2. So we're good there. I have a faculty coordinator for all the intro to stat courses, and I have a faculty coordinator for number theory. All right, so feedback. We have a student advisory board. We meet with them, and we get their feedback. Not just about technology, about everything. What do you think about this? Does it work? Our senior exit survey, we put questions in there to ask them their reactions about the technology they've seen. Was it useful? We discovered from our senior survey that the first course that we a few years back, I don't know how many, we added a correlate requirement of a computer programming course that's offered by the computer science department. What we learned from the student feedback was the course we picked really was terrible as far as preparing them for what we wanted them to know. So we switched courses, and we're currently looking at that course because it's the first course that the computer science majors take, but I looked at all the assignments. The assignments they give are not the computational kinds of things that we want our math majors to see. They're focusing more on writing games and with the object-oriented part of the language as opposed to, doing a math-type problem in the courses. So we're working on that. We have an internship program, and the employer supervisor fills out a form, and I also go and meet with them, and we ask them how well prepared were our students in terms of technology when they came in. Are you satisfied? And most importantly, is there anything we can do to prepare them better. And we've gotten some really good feedback because we send a lot of kids to grad school, but a lot of our students become actuaries and they go into the business world. And in those worlds, like Excel VBA rules. I mean, it does, even though most academics don't see it as being that important. It's out there. I did talk really fast. But where are we? We've come a long way. I'm still bitter about that proofwriting course that the technology was taking. But, you know, patience is a virtue, and I'm sneaking it back in, and hopefully we'll get it back in there. So I'm going to stop here because we're basically out of time. Any questions? Yeah?
The proofwriting course,
Yeah.
who is that? Do you have materials for it?
The proofwriting course is a sophomore course. I'll give you my card, and I'll send you. And the computational math class is another baby. I'm trying to get a book out of that one. So I've written up I wrote up my own notes, and I'm taking a sabbatical in the spring to write that up. But I'll give you my card. And there's also a meet group tomorrow for math educators. So maybe we could hook up there if anyone else is interested. So I think we are out of time, right? Beyond time almost. Thanks.